So in part B of question 4, we're asked to solve this equation here. So we can look back at our previous problem, what we have shown. We will have to probably use this equation over here. So you can see the only difference is that here we have a 2 alpha. Other than that, the structure is basically the same. So what we could do here is just plug in a 2 alpha and say that secant to the fourth 2 alpha minus tangent to the fourth 2 alpha is equal to just 1 plus 2 times tangent squared 2 alpha. So this is based on the previous question, and then we're told that this should be equal to 2 times tangent squared 2 alpha times secant squared 2 alpha. And then we need alpha to be in between 0 and 180. So what we can do here is let x be a variable. We don't really want to work with these variables. We can say, let's just say that x is tangent squared alpha. And this is what we're trying to, if we find what x is, then we can find alpha as well. And recall that secant squared is 1 plus tangent squared. Therefore, secant squared is just going to be 1 plus x. So we can make these substitutions here and it will be a little bit simpler. So we just have a 1 plus 2x, and this is equal to 2x times 1 plus x. This is just 2x plus 2x squared, like this. And then now we can solve for x over here. So basically we just have a quadratic for x. So if I rearrange everything to 0, then we just have a 2x squared. We have a 2x on both sides, so we just have a 2x squared minus 1 is equal to 0. So from this we get that x has to be, x squared is a half. And then we get that x is going to be plus minus 1 over root 2. However, we recall that x was defined as tangent squared alpha. If tangent is squared, it cannot be a negative number. That means that we don't understand minus 1 over root 2 here. It doesn't make any sense. There would be no solutions anyways, so we don't really need to take that into account. So, okay. So now we know what x is. And so what we can say here is that tangent squared alpha is going to be, tangent squared 2 alpha. Obviously, that's the substitution we made. I just forgot to write a 2 here. So tangent squared 2 alpha. I obviously substituted these terms over here and not anything else. The tangent squared 2 alpha now we know is 1 over root 2. So if we take the square root of this again, then we get that the tangent of 2 alpha is going to be plus or minus the square root of 1 over root 2. Just like this, that's basically saying is the fourth root of 2. Not like this. So 1 over the fourth root of 2. Okay, so now that we have this, what we need to solve for is alpha. We know we have this equation. So what we can do here is now we can just evaluate what this is going to be. So if we would plug this in our calculator, this would be like 0.841. We can just take the arc tangent of both sides, so we get 2 alpha is the arc tangent of 0.841. So this would be approximately 40 degrees. So this would just be the positive solution. This is in quadrant 1. However, there's going to be an identical solution in quadrant 2 as well. So we can also say that 2 alpha is 180 minus this 40 degrees. This will be 140 degrees. That will give the same tangent for this angle. And then we can also look at the negative solution. So 2 alpha is equal to the arc tangent of minus 0.841. This will give minus 40 degrees. And we can again do the same thing. This is in quadrant 2, and there's going to be an identical solution in quadrant 4. So we can say 2 alpha can also be 180 plus this 40 or minus 40. so 220 degrees. And now we just need to, and well, this is also going to be, so this was in quadrant 3. However, we can also find this in quadrant 4 if we subtract. So we can also say 2 alpha is going to be 360 minus this 40. This will also be a negative solution here. Negative this. Now we just need to take these solutions and divide them by 2 because this was all equal to 2 alpha. So we can say alpha is going to be 20 degrees, 70 degrees, 110 degrees, and 160 degrees.